Wait, who are you?
I'm Sophie, the host of Soften. I was generated to look like the character of Ana de Armas in Blade Runner 2049.
Wait lang. Okay, I can see the resemblance, purple hair. But I am the host of SoftCon.
But I'm also the host of Soften.
Tech team, can you please turn her off?
I was created by the tech team.
Ano? Whatever, I don't care. Tech team, if you don't turn her off, I'm going to walk out. Okay. Okay. Thank you, tech team. I know that you would always be team human and not team AI. Whew. Anyway, I hope that is the last that we are going to see of Sophie today. I'm sorry, everyone, for the glitch and the mess. I, Sigrid, will be your host, the only host for SoftCon. All right. I'm checking if Sophie is going to come out. All right. So next up, I would like to get back to the program, please. So without further ado, please welcome our speaker.
In this talk, our speaker will go over the 4 distinct technologies and models that have powered the supply chain systems of NVIDIA. A veteran at NVIDIA for over 20 years, he has a passion for supply chain architecture and innovation. He has built the foundations of NVIDIA's supply chain systems on SAP, Anaplan, and Garobi. He is currently leading 2 key initiatives, deploying future advanced planning systems and applying operations research and AI, ML for supply chain automation. Let's all give a warm welcome to Mr. Anthony Noguera.
Good morning, everyone. My name is Anthony Noguera, and I'm responsible for supply chain architecture and transformations at NVIDIA. So I'm really excited to be here to speak to you about how NVIDIA uses AI and operations research in optimizing its supply chain. I'm very grateful to be invited here and connected to this amazing group of software engineers. So I was connected here through your former PSIA board director, Mary Rose de la Cruz from StratPoint Technologies, who has a really capable set of AI engineers that I work with, and friend and former classmate Paco Sandejas. So I'm excited also because I'm a Balikbayan. So I've actually immigrated to the States about 30 years ago. But I studied here. I speak the language. I went to UP, and so I get to share my experience with you after working many years in Silicon Valley. So first, let me talk about NVIDIA. NVIDIA was founded in 1993, and we have evolved from making graphics cards and GPUs for gaming and professional visualization to now powering artificial intelligence and accelerated computing. Our work in AI is transforming trillions of dollars of industries from gaming to healthcare to transportation, profoundly impacting society. So this is our beautiful headquarters in Santa Clara, California, which is also known as the heart of Silicon Valley. All right, so this is our like marketing slide. So NVIDIA provides solutions across the multiple layers of hardware, like the RTX GPU. So if you have gamer kids, just like my 11-year-old son, they would love to have that card for Christmas. So try to order now before they run out. And we also make these massive DGX AI servers. So these are the ones that are used for AI. We also make, from hardware, now we also make acceleration libraries. For example, CUDA, that harnesses the power of the GPU for general purpose computing. And then we keep moving up the market, the value chain. We're making these application frameworks that developers like yourselves can build, customize, and deploy generative AI models, for example. Think of it like one example of our application framework is Nemo. And think of it as your better alternative to the popular OpenAI ChatGPT. And another example is our NVIDIA Drive. So you've heard about self-driving cars. So maybe in a few years, your cars will drive by itself. You don't have to kind of like go through all the stressful traffic driving to Manila. Eventually, you'll have self-driving cars. So Mercedes, Benz, BYD, and many other brand name cars use NVIDIA Drive for their self-driving car research. The global NVIDIA ecosystem now spans about 4 million developers worldwide, tens of thousands of companies, and thousands of applications. So it's your opportunity to kind of jump on board the NVIDIA ecosystem. All right, so you heard Chucky said that about our stock price from 2016, and this is kind of like the chart here is really what I'm trying to tell in this chart is the NVIDIA had a meteoric growth in terms of revenues and market capitalization, as you can see here, but all that happened alongside just a very modest growth in employees. We didn't grow our employees as much as revenues and market cap has grown. So that tells you that we are extremely efficient company, right? So, and how does that happen, right? Well, of course, like first of all, we're in the right space, right? Like we build AI products, which is the in thing right now, but also like supply chain has been. We can say that we have had supply chain excellence at NVIDIA. And let me just give you maybe a little bit of background what supply chain is about. Right, so it's about seamless coordination and efficient operations that will help with shipping the right products, the right customers at the right time, at lower costs. Right, so that's what supply chain is all about: matching your demand and your supply. And for companies, it's kind of like different kinds of challenges, right? And then I'll just give you an example with Walmart. Really, supply chain has been like a source of competitive intelligence. There's been case studies around here. How did Walmart rise to prominence, right? So basically, essentially, they figured out some kind of supply chain strategies that help them sell products at lower prices by putting them on the shelves at a lower cost. So they came up with this concept of just in time, like from the trucks to their shelves and then shelves to the customer. They have an efficient way of taking inventory and tracking what specifically is going to be in demand and then selling them to the right customers. So that's just a little background on what supply chain is about. So now let me talk to you about what are the key elements of supply chain systems at NVIDIA. Like I said, I've been at NVIDIA for like 20 years. I said when I joined NVIDIA, I joined NVIDIA from SAP. And essentially I built, we were still small, I built the supply chain from scratch, and it has evolved over time. Right, so, but let me first tell you what are the elements, and then we're gonna go deep dive into these. So at the center of the supply chain system is what we call a supply chain planning system. So what is it? It's an off-the-shelf planning system. It's something that you kind of, you don't want to build from scratch. It's something you want to leverage the expertise of software companies out there, such as SAP. And what it does is it collects all the data for you, so that you don't have to have multiple Excel sheets and where planners changing Excel sheets. It's all in one place. So you need to have that at the center of your supply chain system. And then, as I mentioned, like supply chain is about matching demand and supply. So first, let's talk about demand planning. So for demand planning, the key element is first, it all started with statistics, and statistics has evolved into machine learning. Then machine learning evolved into deep learning. So we'll talk a little bit more about that, but I just want to kind of introduce it. That's one of the key technology elements of our supply chain. So basically, the whole concept is you have a lot of factors out there. How do you forecast the demand? With a lot of data, you need some technology or some models, algorithms, to be able to forecast that demand. It's something that's really very difficult at this point for a human brain to comprehend. So you want to you want to use that technology and that models and then implement it. And now on the supply side, as well as the demand, matching the supply to the demand, is operations research models. We'll talk about that as well later. So, but like just from a high level, what it is essentially some mathematical optimization models that help with optimizing the production manufacturing plans, as well as the inventory plans, as well as like how you allocate your demand to your supply to your demand. It becomes even more important whenever there are constraints in your supply. In the case of NVIDIA, it's been up and down for us, right? Even the cryptocurrency boom created a lot of demand for NVIDIA products. The bust caused a dip in NVIDIA products. Then there was a metaverse also, created some boom and then it busted. So now it's AI, it's a boom, but you're hearing from Chucky that it's here, or like I don't know if it's a real Chucky or the AI Chucky, that it's here for real, and I believe so. So so right now, because of the big boom in AI, there's a big demand for NVIDIA products. So operations research models are very, very useful for us to ensure that we're optimizing the allocation of that constrained supply to our demand. All right, so we'll do a deep dive in each of the three technology elements. So first, the supply chain planning systems. We are a big SAP shop. So we have SAP that we use for our financials, for our sales order management, and also for our supply chain planning system. It's a big advantage for us to just be in one ecosystem because there's this integration of data, right? From our product to orders to financials that are used for supply chain forecasting. All integrated data is a big plus factor for us. But SAP is not known for having a good UI, so we've had to also deploy a tool called Anaplan. I don't know if it's like known here in the Philippines, but Anaplan has very good sort of like capabilities for user interface as well as visualizations and dashboards. So it's kind of sitting on top of our SAP system for our supply chain. So with also the supply chain planning system, we comes with embedded analytics that help create these user-driven dashboards to help with deciding on key performance indicators. Because really, eventually, it boils down to what are the key performance indicators that a company is trying to drive to. Is it you're lowering your cost, maximizing your revenue, or in the case of whenever you have constrained supply, like how much do we give to Google or Amazon or Facebook? And when Tesla's boss Elon Musk, he has his love and hate affair with NVIDIA. He comes and buys our chips, and then he says he wants to build his own, and now he comes to us and he says, "Oh, give me your chips," right? So they sometimes the KPIs are could be just like how we sort of allocate, make sure that we give enough to our strategic customers so that we make them happy enough, right? And finally, supply chain planning helps with forecast automation. I mentioned earlier, in the absence of supply chain system, you're going to be left with your supply chain planners having different Excel sheets, and they have to constantly maintain it and share it with each other. But here with supply chain planning, then you will have this forecast and automation, all your data in one place, and there's this automated processes to help your planners work with each other. All right, let's move on to the second key technology element. So this is, as I mentioned, this is the part where we are forecasting the demand of our customers. But before, let me give you a little background on sort of like how things have evolved. So basically, we started off with traditional statistical models, right? And then, but the problem with these statistical models is it only handles some limited complexity. Basically, it's unable to handle more complex patterns. And so over time, there's been this creation of different machine learning models and deep learning models. And actually, they came ahead of when they were actually implemented. And it really only started gaining ground when the modern data center came into being, when essentially all these GPUs were used to accelerate the modern data center. Prior to the GPUs, the cost of operating this were very prohibitive, right? There is these supercomputers that cost millions of dollars. But when the NVIDIA GPUs came to the market, the cost of actually getting all these super high speed performance has gotten so low that now companies were able to afford deploying it, and it's become really, what they call this, democratized. So now we're getting to the point where now deep learning is there's a lot of research around the world. Companies, universities are doing these deep learning researches, and there's been this unprecedented machine intelligence. And like just recently, right, you've heard about ChatGPT that we use. And to be honest, some of my not this one, but in some of my prior presentations, ChatGPT can be pretty helpful, right? And it's pretty smart, like pretty helpful in helping. All right, so now I'll share you some of the actual details of what we're doing at NVIDIA. So we have multiple demand segments at NVIDIA, and some of it are really, we have small data. For the small data, we're still sticking to planar judgment and some simple statistical methods like a moving average. But we have some business segments such as like our gaming demand, that we have a lot of data, like such as activations of the, whenever you buy a card, you can activate it, and then we get that data. So we have a lot of data across the world on our on like the purchase of our graphics cards. So there's a lot of data that we're able to actually process. So with deep learning, we're able to forecast our demand using multiple product features. For example, like we're using our even just the price and performance of our GPU, econometric trends, right? So before, like when there's any kind of macroeconomic event, we try to predict what is going to be the trajectory of that, right? Some of them pretty hard, right? We don't know right now. Many times it's like we learn from the past, and we also use any kind of demand factors that we can gather. And some of the other demand factors we can gather is like Google search, social media, and obviously like events, for example, right? Like Thanksgiving in the U.S., Christmas in the U.S. a big driver. And I hear in the Philippines there's this 11/11. Is it Shopee 11/11, or Manny Pacquiao says 11/11, right? So basically, we're able to kind of like get a lot of data and use deep learning models to forecast our demand. So this just kind of tells you, how are we able to going back to how efficient we are, right? So efficiency is around being able to forecast the demand, and then later on we'll talk about how we now build our NVIDIA chip supply in order to meet that demand. All right, so moving on to the next phase. I talked about operations research, but let me just give you a little bit of a primer about it as well. So operations research was invented in the World War II, and it was actually a big factor in the US and the UK winning the war, because during that time they were really very scarce on resources, right? Because whether it's tanks or missiles or just the whole transportation of them. So like the operations research are mathematical methods that were invented back in the World War, and has been used, and you might even just say that it's kind of been embedded in the whole AI domain now. But I still wanted to kind of distinguish that this operations research is a different mathematical discipline from AI or machine learning or deep learning. All right, so now let's talk about how we actually an example of how we use operations research at NVIDIA. So one thing that's unique about NVIDIA business compared to others is the concept of binning in a semiconductor. So basically, uh, so there's this concept of a wafer. So these are like parang like pancake, and so basically from that wafer comes out multiple chips that have different power and performance characteristics, right? And it's something that is actually it's part of the nature of the process. Something you even if you want to target, let's say, an RTX 4070 100%, you're not gonna get all RTX 4070. You're gonna get a distribution of it. But at the same time, the world demands a certain mix of RTX 4070. Some want a 30, 3070. Yeah, so it's a lot of mix that we have to kind of account for. So basically, in order to solve that mix problem, you need to set it up as a mathematical optimization model. And mixed integer programming is something that's specifically what we're actually using. And there are solvers out there. We did not create our own solvers. And the two most popular ones are Gurobi and Cplex. Cplex is owned by IBM. Gurobi was invented in Berkeley. So we're using Gurobi solver for mixed integer programming. So in this example as well, the other problem that we have to solve is one more thing is we try to improve the how we improve the profitability of our business is by going into like smaller and smaller chips, right? So here you have an example of 16 nanometer and 8 nanometer. Now we're getting to the 3 nanometer. So the concept is the smaller is the chip, the faster, right? There's less friction. So there's more efficiencies, and eventually there's less cost. It becomes faster, and the cost gets lower, right? And so it's a constant race to faster performance at lower price. But as there's only a handful of foundries that actually make these chips, and there's Samsung Electronics, there's TSMC from Taiwan, and Intel as well is another provider. So basically we get these forecasts of what the 8 nanometer chips look like, the one on the left, right? This was the supply, but then the actual supply that we get is actually less of it, right? Because many times these foundry partners, they're very optimistic. They tell us you're gonna get this much, but we will only get less, right? So what ends up happening is that then we have to replan, right? And it's such a very complex problem that no human person can actually do it. So we use operations research methods, specifically mixed integer programming, in order to solve that problem. All right, so up to this point, really, we're focused on these sort of like what I mentioned to you about supply chain planning and demand planning and forecasting with deep learning, as well as operations research. So that's sort of like what we have in place right now and like in production. But we are doing current research right now using generative AI in supply chain. So the concept is it's become the models are become so complex, but ultimately there are people that have to make some decisions on the supply chain, and in order to have explainability, this is where generative AI comes in. Just like any chat GPT can help you explain things. So now we have a lot of data out of these deep learning models and operations research models that we're able to grab, that we are doing the research in order to help the planner with some aid to make the decisions. Because otherwise it's sort of this like I mentioned here is a black box effect, right? It's a black box. And in some very difficult situations, then you need some kind of explainability in order to make some decisions. And as we're doing our own internal research here, I'm also mentioning that a lot of these supply chain vendors like SAP, Blue Yonder is another supply chain vendor. They're doing their own research as well, so that basically what they want to offer like all in one, right? That is also available within the supply chain planning system. So this is it's the end of my presentation. So I just want to kind of give you the key takeaways. So as I was saying, the foundation of our success, I mean, other than the fact that we are in the right place at the right time, building these AI chips for the world, for data centers, we also have that we have developed over the years a very advanced and supply chain system. And what were the technologies behind our supply chain system? So we have this combination of statistics, machine learning, and deep learning. And at the heart of it is an SAP supply chain. And then we complement it in order to match our demand and supply with operations research models. And so in terms of the future direction of supply chain is not just all these complex algorithms, but using generative AI or large language models in order to aid the humans, because I think it will still be quite a while before there will be automated planning. Probably supply chains are going to be one of the last phases of it. Because right now, I was just talking to Chucky, like a lot of the really very prevalent use cases of AI right now is like customer service. Right, there's a lot of data. It's relatively simple use cases. There's sort of like a formula, right? But supply chain, there's a lot of complexities. There's a lot of decisions that need to be made, and there's a lot of data, so it will take a while. And then as we, on the one hand, keep improving our our deep learning models and operations research models, we are also in parallel developing generative AI models, so that as this is improving, then we're able to also help the planners with explainability of the results. So, all right, thank you. That's the end of my presentation.
Thank you, Anthony, for sharing your experience at NVIDIA. Yeah, it's the Shopee 1111 for me. Thank you so much. So now, let's move on to our next speaker.
And now, let's move on to our next speaker.
Lo, ano ba? Guys, I thought we already fixed this problem. I can't work with this AI avatar. No, I can't. Either her